Hi all, today we are going to start with the new subject electric drives. For the smooth understanding of the topics covered in this subject, you must be aware about the concepts which you have studied in both power electronics course as well as in electrical machines course. As this subject is actually a fusion of both this power electronics and electrical machines. In this subject, the first module mainly covers the introductory course, that is the introduction to electric drives. The second and third module covers the DC drives. Fourth and fifth module covers the induction motor drives, whereas sixth module is covering the synchronous motor drives. So we are beginning with the first module, that is introduction to electrical drives. Motion control is actually required in both domestic as well as industrial applications. While considering the domestic applications, you yourself will be able to see that motion control is actually required in ceiling fans, mixie, grinders, washing machines, etc. While in industrial applications, you will be able to see that motion control is required in transportation systems, textile industries, paper industries, machining tools, etc. Basically, this industrial drive will consist of a mechanical load. This mechanical load is actually kept in motion to do a particular task. And the device which is required to do this task is said to be the prime mover, and the connection between this prime mover and this mechanical load is actually achieved by using a transmission system. So this is actually the basic structure of a industrial drive. There can be different prime movers to be used to achieve this particular motion control. They are diesel or petrol engines, gas or steam turbines, steam engines, hydraulic motors, electric motors, etc. So those drives which employ electric motors as prime movers are called as electrical drives. So far I have said about the introduction of drives, and in specifically electric drives are those drives which are employing electric motors as the prime movers. Consider the case of a DC motor drive. In specific, consider a DC series motor drive. In the case of a DC series motor, the speed control can be achieved by either using a field diverter method or tapped field control method. You are aware about those techniques from your previous machines course. In those techniques, we will be using either a field diverter or a tapped series field controller to achieve the desired speed control. So it's very clear that some sort of tools we will be using to achieve the desired speed control. The desired speed control means we will be obtaining the operating point in a specific characteristics to achieve the desired task of operation. This is just a diagrammatic representation of the actual industrial drive. Here you will be able to see a user interface. Through this user interface, you will be able to achieve the desired speed of operation of this motor, and that particular desired speed of operation will be required for a particular application. This diagram is given only for representation purpose. These are the examples of electrical drives. That is, electrical drives can be used for industrial applications as well as domestic applications. In industrial applications, they will be used in textile mills, transportation systems, machine tools, etc. While in domestic applications, we will be using it in fans, washing machines, etc. We have already mentioned about this. Now we will look into the advantages of electrical drives. Comparing with that of the other prime movers, these electrical motor drives are pollution free. That is one of the main attraction of electrical drives in the current scenario. Another major advantage of this electric drive is their flexible control characteristics. If you are considering the example of an induction motor drive, you have already studied about the torque slip characteristics of an induction motor. By varying the supply voltage or supply frequency, or both the supply voltage and frequency, that is V by F method of speed control, provided at the input side of the induction motor, you will be able to fix the operating point anywhere in the stable region of the torque slip characteristics of the induction motor according to the load requirement. That is, based on the load requirement, we can vary the operating points in the torque slip characteristics of an induction motor. That is possible either by varying its supply voltage or supply frequency, or both supply voltage as well as supply frequency. This change in supply voltage or supply frequency or both voltage and frequency can be achieved with the help of semiconductor converters. Those semiconductor converters you have studied in your power electronic course, that is rectifier, inverters, cycloconverters, etc. That is, with the help of this semiconductor converters and microcontrollers, we will be able to achieve, or we will be able to tap the exact operating point required for the load. The main exquisite feature of this electric drives is that they are having the particular feature of adaptability to any operating conditions such as explosive and radioactive environments, or let it be in submerged in liquids, etc. These electric motors are having higher efficiency comparing with the other prime movers, and their no load losses are also very less. Moreover, they are having a short time overloading capability. That is, for a short span of time, these electric motors can be overloaded without causing any harm to the electric device. Next, we are going to study about the block diagram of an electric drive. This is the typical block diagram representation of an electric drive. This has been asked in the previous year university question papers several times. You have to draw this block diagram and give a brief description about the components which are being used here. So the components used here are source, power modulator, motor, load. This is actually the mechanical load through which our desired task will be achieved. Then we will be having a sensing unit and a control unit. Now we will be looking into each of this block in detail. First, we will see the block source. Different types of electrical sources are employed based upon the applications. While considering the case of electric traction in India, we will be using a 25 kilowatt 50 Hz supply. While coming to the underground traction system, we will be employing a low voltage 500 to 750 volt DC supply. Whereas in the case of aircraft and space applications, we will be using a 400 Hz AC supply. We are using very large frequency AC supply in the case of space applications. This is mainly to reduce the size and weight of the devices used on board. Small and medium power rating motors are generally fed from 400 volt supply, whereas high rating motors are fed from 3300 volt or 11 kV or much higher than that. You must be able to write at least some of them in order to fetch the marks in university exam. Next block we are going to handle is the electrical machines. As all of you are aware about this, there are various types of electrical machines, that is DC motors, AC motors and special motors. You have already studied about them in detail in your previous semesters. Next important block is the power modulators. This power modulator actually interfaces the motor with the source. The main functions of this power modulator is actually modulates the flow of power from the source to the motor. Another major function is during the transient conditions, that is during starting or braking or under the condition of speed reversal, there is a chance for this motor to take a large amount of current from the source. So this current control can be also achieved by using this power modulator. So with the help of this power modulator, such a large amount of current won't flow to this motor, thereby it will protect the motor also. Another major purpose of this power modulator is to convert the energy into the suitable form required for this motor. Depending upon the source and the type of motor which is being used, these power modulators are classified into various types. The different types of power modulators are explained here. You have studied about them in detail in power electronics course. The first type of power modulator is AC to DC converters. They are actually controlled rectifiers. In this power modulator, the input will be of fixed AC voltage and the output will be of a variable DC supply. If we are using diode based rectifiers, then the output will be of constant one. Whereas if we are using control rectifiers, the output will be, control rectifiers means the devices used will be either of SCRs or MOSFET or IGBTs. Then the output will be of variable DC in nature. The next type of power modulator is DC to AC converters. In this case, the input will be a fixed DC and the output which we will be obtaining is of a variable AC. This is also said to be inverters. Generally used inverters are of PWM inverters. In order to obtain a sinusoidal output waveform at the inverter, we will be using SPWM inverter, that is sinusoidal PWM inverters. There are two types of AC to AC converters. One is said to be the AC controller and the other is said to be the cycloconverter. The distinguishing feature between them are, in the case of AC to AC converters, that is in AC controller, the input AC will be of fixed in nature and the output AC will be having a variable magnitude, keeping the frequency constant. Whereas in the case of cycloconverter, the input AC voltage is fixed in nature, the output magnitude also will be fixed in nature. We will be able to change the frequency, that is the frequency of input voltage, and output voltage will be different, keeping the magnitude as a constant one. The last type of power modulator is actually DC to DC converters. These are also said to be choppers. The other name of this is said to be DC transformers. In the case of DC to DC converters, you have studied about them in power electronics course. There is buck converter as well as a boost converter. The input DC voltage will be fixed in nature and the output DC will be variable one. It will be either greater than the input DC magnitude or it will be lesser than the input DC magnitude. Based on that, they are classified into boost and buck converters. So these are the various types of power modulators which are generally used in electric drives. A specific type of power modulator among them are chosen depending upon the type of source and the type of machine or the type of motor which we are using in the drive. Next major element in the block diagram of electric drive is control unit. This control unit is actually a low power complex circuitry which is being fed by a low voltage supply. This control unit mainly consists of a firing circuit which is being made up of linear and digital integrated circuits and transistors. When sophisticated control is required, we will be using either DSP controllers or microcontrollers. The basic function of this control unit is to monitor the system variables and compare them with the desired variables. While making this comparison, error signal will be generated. In order to compensate that error, the firing circuit will be adjusted so as to generate the firing signals for the devices in the power modulator in such a way that the desired performance of the motor can be achieved. That is, consider the case if you want this load to be made to rotate at a speed of 5000 rpm. You will be giving the input command of 5000 rpm here. And in this current situation, if the motor is running at 4500 rpm, so definitely there will be a while comparing this desired input and this monitored input, definitely there will be an error signal of 500 rpm. So accordingly, we will be coding it in the microcontroller in such a way that the firing signals will be adjusted to compensate for this error of 500 rpm. So that firing signals will be provided to the devices which are present in this converter. Thereby the supply to the input supply to the motor can be varied and the motor can be made to run at the speed of 5000 rpm. So this control unit block will be continuously monitoring this system parameters, and this comparison with the desired parameters will be continuously done by this control unit, and hence the desired performance can be achieved. Another major function of this control unit is it generates commands for the protection of this power modulators as well as for the protection of the motor. That is, in any case, if the motor is taking very large current than the rated current, then while sensing this input parameters, this control unit comes to know that the motor has taken a very large current for a very small interval of time. Then suddenly the relay circuit in this will trip the gating circuit. Simultaneously, there will not be any gate signals provided to this power modulator. Hence thereafter, no supply will be given to the motor. Literally we can say that whenever there occurs a faulty condition, this control unit will act as a trip circuit for both power modulators as well as for this motor. Thereby it provides a protection circuit for both power modulator as well as the motor circuit. Hence we can say that this control unit is actually an inevitable part in this block diagram. Next major unit in the block diagram of electric drive is the sensing unit. These are actually the various sensors which are used to sense the speed, torque, current, voltage, position, temperature, etc. With this we have completed all the elements in the block diagram of an electric drive. As I mentioned before, this block diagram of electric drive and the explanation of each element is very important. They are repeatedly asked in the previous year university question papers. Next we are going to study about the various factors which must be taken into consideration while selecting a particular electric drive for an application. You just cannot choose in random an electric drive for any sort of application. The various factors must be taken into consideration before choosing an electric drive for a particular application. Those factors are given here. The first factor which is taken into consideration is the steady state operation requirements. The second factor is transient operation requirements. Transient operation means when the motor is in starting condition or in braking condition or in the case of speed reversal. Such sort of cases are coming under the transient operation conditions. Steady state operation requirements while considering the case of smooth running of the motor. The factors which come into consideration are their speed torque characteristics and the quadrant of operation. Speed regulation, you have already studied what is actually the speed regulation, their efficiency, etc. Next major factor is depending upon the type of source, the electric source which is available there. If the source available there is a DC source, then accordingly we have to choose a DC drive based upon our load requirement. If the source available is AC, then accordingly we have to choose an AC drive. It's not only just the type of source what matters, the voltage level of source, harmonics and their effects on the other devices and their ability to accept regenerative power. All these factors must be taken into consideration while choosing an electric drive. The remaining ones are the usual ones, the capital and running cost, space and weight restrictions, environment and location, and reliability. These are the usual type of constraints which we generally taken into consideration in all systems. This was also asked for 4 marks in the last year university question paper. Next is the classification of electric drives. Electric drives are generally classified into group electric drives, multi-motor drives and individual drive. This group electric drive is also called as shaft drive. In group electric drive we will be using only a single motor. By using this single motor, numerous machines are driven. Such a system is being achieved by using numerous shafts and bearings which are being interconnected with the help of belts or gears. The main advantage of this group electric drive is with the help of a single motor, numerous machines can be driven. So while considering the diversity factor of these loads, the rating of the motor chosen can be small. There is also another added benefit of this group electric drive. The major disadvantages are if any fault is occurring in this motor, the whole system becomes inoperative. Another disadvantage is the whole system appears to be a chaos look or untidy look due to this numerous connections of shaft, pulleys and belt bearings, etc. In addition to this, the noise produced in this arrangement is also quite large. A very good example of this is actually floor mill. You might have seen floor mill. We will be using either 1 or 2 motors, and with that we will be using various machines for grinding, milling, etc. So you might have seen how untidy a floor mill seems to be like. Next classification of electric drive is individual drive. In this individual drive, a single motor is used for transmitting motion to various parts of the same equipment. There is a single motor is used for transmitting motion to various mechanisms of the same equipment. A very good example for this individual drive is lathe. You have seen them in your first year laboratories. While comparing this individual drive with that of the group drive, the common thing is both these drives make use of only a single motor. Next classification is multi-motor drive. In multi-motor drive, different motors, you will be able to see here, different motors are used for actuating different parts of a driving mechanism. A very good example for this multi-motor drive is traveling cranes. In traveling crane, Actually, three motors are used. One motor is used for hoisting, the other one is for long travel motion, and the third one is used for cross travel motion. That is, these three motors are used for actuating the different parts of this driving mechanism. The driving mechanism which we are using here is actually this traveling crane. And the various mechanisms are long travel motion, cross travel motion, and hoisting. With that, we have completed the classification of electric drives. You don't need to study or by heart the diagram of these drives. These diagrams are represented here only for understanding purpose. You just need to know, or you must be able to know the concept of this classification, like how each are distinguished from others. Next, we will see the distinguishing features between DC drive and AC drive. At least 4 of the distinguishing features you must know. The first distinguishing feature is the power circuit and control circuits are simple and inexpensive in the case of a DC drive. DC drives requires frequent maintenance. The phenomena of commutation acts as a main restraining factor in the case of DC drive. Commutation means whenever a conductor which is lying under the effect of north pole is moving towards the effect of south pole, the direction of current in them must be reversed. So this circuit arrangement for proper commutation makes the motor bulky, costly, and heavy. And moreover, this commutation also puts restrictions on the speed and design ratings. Another distinguishing feature is regarding the environment. The DC drive can be used in certain locations only, whereas AC drives can be used in all locations. This is also a major distinguishing factor. In the case of DC drive, the power per weight ratio is small, whereas in the case of AC drive, power per weight ratio is very large. With this, we are completing today's session of Introduction to Electric Drives. All of you must draw the block diagram of electric drive in your notebook, and you may take a snap of it and post it in our WhatsApp group. Thank you.